Hi everyone. So today I'll be running over the Jug tutorial. So we did this live a couple of months ago. This is for those who couldn't make it to the live version or who want to recap. And I'll go ahead and get started immediately. So you have all of the information in the links in the description. So you can follow along at home. Everything is publicly available. So the very first thing I'm going to do is I'm going to create a new content environment. I'm going to call it Jug tutorial. I include Python. I'm using version 3.9, but it really shouldn't matter as long as it's 3.6 or older. Then Jug, and then a couple of helper packages. And in this case, because I had pre-downloaded everything before this recording, it's going to be very fast. It might take a couple of minutes on your side, especially if you have a slower internet connection. Then I'm also already pre-cloned the GitHub repository. Again, the description is in the notes below. And so at the base of this repository, I have there's a README file, and then there's this hello directory, and that's where we're going to start. So hello, there's two files, hello many, and jugfile.py. So I'm going to start with the jugfile.py. So this is Python. So if you don't know Python, then really you should go learn it, come back. If you do know, then you will recognize that this is a almost standard Python file. I mean, here, if we ignore these lines for now, yeah, we define a function called hello world that writes the string hello world to a file called hello. That's it. We define the function, and then we call the function. But by adding these two, first this import statement, and then decorating the function as a task generator, now here in this last line, whilst it seems that we are calling the function hello world, we are in fact generating a task called hello world. And if we use Jug, and so Jug, I'm going to just adjust this a bit. Jug uses a subcommand interface. So there's a command Jug, and then we type a subcommand. So here the first subcommand will be status. You can see that the status of this is that there's a task called hello world that's ready to be run, but we haven't run it. We haven't executed the task. If I call Jug execute, it will now execute the task. I'm going to finish quite quickly. And if I look in the directory, I will see that there's this hello.txt file with the string hello world. And there's also this weird jugfile.jugdata subdirectory that we are going to ignore for now. If I look at the Jug status, now the task is no longer ready. It's in fact complete. So we moved statuses. And if I try to execute again, then it will actually do nothing. It will show me that the 0 tasks were executed and 1 task was loaded. This means that it was already done, so the outputs could be loaded. Okay, so this is the basic mechanics of Jug using a very simple task. In this case, we got nothing out of using Jug. We could have just used a Python file and gotten the same thing. So let's build up and look at this hello many. Hello many, slightly different, but same imports at the beginning. But now instead of the function being called hello world, it's called hello, and it takes an argument. And we'll be using this throughout, where we add the sleep call so that things don't finish in a second or two. Otherwise, it just for showing how it works, it's too artificial as it is. And now each one of these, each time that the function hello is called, it will say hello to whomever you ask it to. And here then we loop over and we say hello to all of these people, right? So now effectively we will be calling hello 6 times. And so now if you're paying close attention, you'll see that I've set Jug status hello many. So if I don't tell Jug which file to use, it will look for a file called jugfile.py. Otherwise, I need to tell it. But but other than that, that's the only reason to call it jugfile.py is to save this little typing step here. Okay, now I can run execute. I'll run it in the background, and now it's executing. And if I look at the status, you can see that 5 tasks are ready and 1 is active, meaning that there's a process taking care of it. And in fact, I can add the second process that's now running this task. And if I look at status, now there's 2 processes that are active. In this case, now 2 have completed, and now everyone finishes. So this is the standard mechanics of Jug. So status looks at the status of the different tasks, executes a task, and you can run multiple processors simultaneously, and they're independent processors. So these are independent, here Linux tasks, but they coordinate amongst each other so that each one will execute a different set of tasks. So they're using these special directories, JugData, to lock and to. We're not going to go into all of that machinery, but there's a lot of machinery here to ensure that you can throw as many different processes as you have, be it on the same computer or across a computer cluster, and things will work. And now, hello many, this is done. And if I try to execute, it will finish, very quickly. It just checks that everything is done, and that's it. But okay, let's say that this program has said hello to many people, but it actually didn't say hello to me or to Rita. So let's just add a couple more names. And now we used to have 6 tasks, and now we have 8. And if you look at the status, well, the previous 6 ones are already complete. So as we execute now, only the new ones have to be executed. So this is a very typical situation in a development process where, as you are developing, you keep adding more and more to your growing pipeline. And so it's very helpful to be able to reuse partial results. Okay, and now this is done. And all of these files were created. And just so we're sure that there's really no magic. So if we delete all of the txt files, we can trick Jug, and it still thinks that all of the that all of the tasks are complete. So there's no and if we remove the JugData directory, now we have reset, and now everything's ready to run. And now we could run it again. I'm going to run a few ins. So I could run several at the same time. Here, everything's running locally, and they all finish quite quickly. Okay, so this was the basic, the very, very basic. Now let's go for a slightly less basic example. And so I'm going to show you this gc const directory. And first, I'm going to discuss the problem. This is, if you don't know anything about bioinformatics, that's fine. It's really very, very simple. But we have these 14 files inside this demo data directory. And this is real data from the GMGC 1.0, so the Global Microbial Gene Catalog version 1.0, except, and this is very important, we've only taken the very top of the data. This is a toy data set. This is not the full data. So none of the conclusions that we draw here have any validity. Actually, this is, it's not a ridiculous analysis to run, but it's a toy data set. So we should not look at the conclusions. It's just that I needed something that finishes in some reasonable amount of time, and this is going to take a couple of minutes as opposed to several hours of computation. So these are FASTA files. So we don't need to go into the details of but you have these alternating header line. So this is, and then you have the actual nucleotide sequence. So this is DNA, A, T, C, and Gs. And our only question here is to count whether the fraction of C's and G's is different in these different habitats. So here we have microbes that live in the built environment, in the cat gut, in fresh water. Do some of these habitats have tendentially more G's and C's compared to others? So that's it's not an unreasonable question to ask biologically. We're just going to ask it here. Okay, and here, so we have a couple of files. We have this FASTA file. Not really going to look into it, except just to show you that it's a completely standard Python file. Provides this function called FASTA iter that iterates over a FASTA file that as I just showed you, has nothing to do with Jug. And then we have here 4 Jug files, and the way we use this is these represent different stages of development. So we're going to start with Jug file 1, and I'm going to just rename them one by one to Jug file because they built upon each other. Okay, again, very standard Python code, except here we've used these task generator decorators and define this function process. It's what it's going to do, takes as an argument an input file name and outputs a table or generates a table in a file and returns that. Again, we're going to use this sleep trick to pretend we're actually doing a lot of work. And then we use the glob. So if you're not familiar with glob, this is the same as you have on the command line. So so the star expands into all of these input files. We sort them just to make sure that the order is kept consistent, and then we process one by one. Okay, so if I look status, all of these are ready to run, and I can execute a couple in parallel. So here in this case, I execute 4 in parallel. And here again, if this could have been running in a compute cluster where the 4 could be running in completely separate nodes, I can add them maybe some start now and the queue is very busy, some start in half an hour, and all of that's okay. Jug will take care of that, and as long as things eventually run, eventually everything's good, right? All right, and eventually, okay. So what did this do? So this generated these output files where here, yeah. So you have here these identifiers, and then this one had 37 A's, 39 T's, G's, and C's. There's also an N that means unknown, but yeah, okay. So we've counted the different letters in each sequence. So what's the next step? So well, the next step, let's say is to really now compare compute the fraction of G's and C's. And so again, we add a new function, this GC fraction function, that executes this, G plus C over G plus C plus D plus A, and calls it GFC. And yeah, so here whereas before we only called the first step in the process, now we move on to the next step, and we save everything in a dictionary. I'm going to call it these partial results. Okay. As before, the process tasks are complete, so we can reuse them, and we just execute. And here, because we didn't use any sleeping, it was actually quite fast. Okay, so we're making progress. And at this point, I'm going to show you something else. I'm going to show you that we can use this shell subcommand, and it drops us into a shell. This is a Python shell, or it's actually an IPython shell. So we can do Python high, but the interesting thing as well is that we have access directly to the variables that are defined in our Jug file. So I can have access to I files, and this is all of these inputs, and I have access to, did I spell that correct? Yeah, to partials, for example. And here it's a dictionary where the keys are these strings that correspond to the file names, and the values are these things here. These are task objects. So a task object, this is the internal Jug representation of the computation that's necessary to generate this result. And just to maybe for those that are interested in looking at the magic, these are hashed so that each one has a unique hash. And if I look now at these weird files in this Jug file .jug data directory, I can find the corresponding hash file there. And so this file will store the result of this task. So generally, we don't really need to look into this. I'm just showing you a bit behind the curtain. What we generally want to use functions such as value that loads the task result. And actually, it's a little bit more flexible because we can load compositive objects, such as dictionaries, lists, floats, and then tuples. And then it's going to load every subcomponent and return it. And here, for example, we could use this to build into a pandas data frame, look at the values, maybe, for example, sort them. Yeah. And so here, and again, this is really toy data, but here we could, if this was not toy data, we'd start to look, oh, look, this one has a significant lower GC content than that one. And we could explore here using this interface where we can load bits and pieces of our results. We can use it for debugging, etc., etc. Okay. So this is moving on. So this is what the new. So what I could develop this on the shell and then convert it to a file, and here sort of write it to the script, and here added in this new step, this build table step. And so this is a very typical fan in, fan out type of structure where we have a lot of input files. They can be processed independently, and then we combine all of them. And so often then the next step we'll get some parallelism back and then combining them, etc. A few years ago, there was this fad, something called MapReduce, which was exactly just this type of structure where we have a lot of parallelism in some steps of the pipeline, and then we need to combine, then a lot of parallelism again, and then combine. And Jug handles this very, very well. Okay, so having looked at these results, maybe we would like to, for example, do a little plotting, and this is what we do in the last step. So now we add this plot results function, and add some very basic data munging, and then saves it as a file. Right? And now, if I run it, it's going to take a couple of seconds, and boom, there it is. And I can open the file. And again, yeah. So here's our output. So not particularly beautiful looking, but we could see that here. Here I've plotted different quartiles to not just give the mean, but a little bit of the idea of notion of that there's variance in these data, but even then, there's also some differences. Okay, so this would be one way to work. Another way to work that's quite common is that you first run a lot of computation, and you might even use the compute cluster to run everything that's heavy computation, where you're processing large files or you have a lot of data, and for that, Jug really is a very good solution. But then you get to this next stage where you're exploring the data, you are plotting it, you're building tables, and for that you want to be a bit more interactive or use. And so here I showed you the Jug shell, or you want to use a more standard Python, and you want to be able to load the results from Jug. And here I'll show you now how here's this plot results file, very standard Python. And here I'm using Jug just as a library where I initialize. I can have to be a bit more explicit initializing, saying that, okay, well, I want to get the results from this jugfile.py that are stored in this jugfile.jugdata directory, and then I can use this value function to load them, and it will do exactly the same that I showed you in the shell, except this is now a file that you can save and even run, and it will run now as a Python command, or if you're using Spider or some sort of other or IDE, you could obtain the results that you got from Jug and load them like this. All right, and the final way I'll show you how to do it. And I think I need to install it quickly. So I'll install the Jupyter Notebook. And so here I've used Mamba. So just a bit of a side note, but if you're familiar with Conda, you might also be familiar with the fact that Conda sometimes takes a long time to process. And so just switch to Mamba. It's almost a drop-in replacement. Wherever you previously spelled Conda, you spell Mamba. Even the same number of letters, and you get exactly the same thing. It's just you get it much faster. Okay. As I say that, we do need to wait a couple of seconds. Okay. Yeah. Yeah. Okay. So in this case, I've also already previously downloaded everything. So I need to just be sure that I'm Jupyter Notebook, just to make sure that I'm using the right one. Yep. Jupyter Notebook, and same thing. Okay. All right. I apologize, for some reason my Jupyter is in Chinese. But yeah, so here's this. Since everything is done in Python, we can just run the same Python things we were running before, where we explicitly import this Jug functionality and then look at the data. And here we can get these sort of this neat little functionality that comes from the IPython notebook or the Jupyter notebook, and do the plotting, saving, etc. Final reminder, don't take any scientific conclusions from this data set. It's not real data, but it was a demonstration of something that would have been a real analysis. So this script, if we had fed it, not these toy data sets, but the real data, we would just have to wait a lot longer for the computation, but the script would run. And then we could use one of these different methods to get the results and to take advantage of high performance computing, to take advantage of having cached results, so that if we want to add a new analysis, we don't need to run everything from scratch. So links below to the Jug web page, the Jug manuscript, the tutorial. There's our Discord server or the mailing list. So feel free to hit us up with questions if you have any. And otherwise, you can subscribe. We'll have other tutorials on this channel pretty soon. All right, take care, everyone.